Hello, my name is James Buckley, and this is my lab on finding the coefficient of friction. So, for this lab, we are asked to determine the coefficient of kinetic friction between the IOLab device and any surface to have friction present. We are determining the coefficient mu between the two objects and how well we can predict it using calculations. Google Sheets will be used to determine the full calculations of the friction coefficients. For our trial, we place the IOLab device on the Y direction with the wheels facing upwards and place it on a flat, rugged carpet. Once placed on the carpet, we will push the device across it and record its acceleration and force using the accelerometer and force sensors located in the Y direction. 8 data points will be recorded using Google Sheets and I will explain how we do that in the next slide. Felt stickers will be put at the bottom to have a better chance of actually predict the kinetic friction. For this experiment, our units for kinetic friction will be beta 0 for kinetic friction and beta 1, which will be static friction. I'll explain that also in the next few slides. The experiment was designed this way to test the frictional force between the device and a flat surface. Some assumptions going into this: since the carpet is made of material that is very rough, the coefficient for both forms of friction is to be very high, which will prevent the device from moving a great distance over time. I'd also assume the value of kinetic friction will be higher than static friction, since the object is in motion. Data collection of the carpet. Sent above is the acceleration, the graph for that, and below is the force. And as you can see, the highlighted region over here represents how we got our data. We got the averages of the force and the acceleration and placed them in the units right here. And we also got the standard deviations. We also said that the maximum static friction was around when the force was 5.131 newtons and the the acceleration is 3.165 meters per second squared. The graph showed a large trend in a positive force. However, the acceleration was not constant throughout this trial and changed from positive to negative multiple times. Graph data. The beta 1 was the static friction, 0.286, while the beta 0 was kinetic friction, which was 1.827. Y-intercepts represent beta 0, which represented the kinetic friction, while the slope, beta 1, represent the coefficient of static friction. Graph showed as force increased, so would the acceleration and the slope of the static friction. While the data presented some insight on how to accurately solve all for the friction, it was far from accurate. The coefficient of kinetic friction was over its threshold of 0.0 to 1.0. Coefficient of friction was determined to be 1.8. This means that there is some inconsistency in the experiment which required modification to improve the data. Some limitations that could have caused this was it was not entirely a flat surface. Carpet was very misshapen, not a completely constant acceleration due to human error, smaller margin of time which could show inconclusive results, and possible calibration error. For this experiment, we placed the device on a large wooden floor and pushed it across for a longer time interval of 8 seconds. This was done to give it to see how a smoother surface can test the friction between the device and the surface and can be recorded more accurately without too much trouble pushing it across a jagged plane. So here we had data collected above, and for the graph, it this time showed a negative static friction, which, as you can see, is above here. We found the coefficients. As you can see, the data presented for the slope now showed a negative slope for the static friction. How this was determined was not discovered. It could have been a calibration error, as stated before. Since we swapped out a different device, was used in this trial, yet that was never determined. Possible calculation error that could be corrected as well. Final analysis: in both trials, the magnitude for both the static and kinetic friction were nowhere near equal to each other. In both trials, the kinetic friction beta 0 was the higher value. Kinetic friction should be the friction value that is higher than the other value of static friction, since there is a force applied to make the device be pushed in the desired direction. Static friction is the force that tries to prevent the device from moving. Since the device was in motion the whole trial, static friction would be lower since the device is in motion. While both trials showed possible inconclusive results that can result in further experimentation, there is no doubt the conclusion that kinetic friction is a higher value of the two. Thank you so much for listening, and I really appreciate it.